ಹಲೋ ಚಿಕ್
ಇದು ಕನೆಕ್ಟ್ ಆಗಿಲ್ಲ ನೋಡ್ರಿ ಇದ ಮೈಕ್ರೋಫೋನ್.
ಹಲೋ ಹಲೋ ಚಿಕ್ ಚಿಕ್ ಹಲೋ 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 ಚಿಕ್ ಹಲೋ ಚಿಕ್ ಹಲೋ 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 ಚಿಕ್ ಹಲೋ ಹಲೋ ಹಲೋ
ಹಲೋ ಹಲೋ
ಹಲೋ
There are dreamers and there are the planners. The planners make their dream come true. A pleasant morning to one and all present over here. I, Soumya from 5th Sem CSE department,
And I, Shilpa from 5th Sem CSE department,
are present before you to take through a knowledgeable journey. The day 4 first session to be held on topic Case Studies and Future Trends in IoT by Dr. Pramod Elmewad sir from IIIT Dharwad.
Now I would request Sakshi Nayak to introduce our resource person to the gathering.
A pleasant morning to one and all present over here. I take the immense pleasure to introduce our resource person, Dr. Pramod Elmewadi. Sir is an assistant professor at CSE Department, IIIT Dharwad. His research expertise in high performance computing, parallel algorithm and IoT. Sir has published several journal articles and conference papers. Sir is a reviver for esteemed journals like IEEE Transaction on Knowledge and Data Engineering, Parallel Computing, Supercomputing, and IEEE conferences. It's an honor to have you among us, sir. Thank you.
Thank you, Sakshi.
Now, I would like to request Dr. S.G. Golagi to welcome Dr. Pramod Elmewad. Thank you, sir.
Today to
Hello, hello. Yeah, that's
Today to enlighten us about IoT design and development, we would like to invite Dr. Pramod Elmewadi.
So, good morning, all. So, let's start today's session. So, I think we are late by almost half an hour for today's talk, actually. So, my talk is basically on IoT design and development. So, while introducing myself, your speaker has done one mistake. She was telling I will be talking on case studies, IoT case studies actually. So basically, I changed my topic. So there will be another resource persons to talk on IoT case studies actually. So here, in today's session, I will be talking on IoT design and its development actually. So guys, at this time, I hope you guys are well familiar with what IoT is, what IoT system means actually. Now, in today's session, we'll be giving more emphasis on knowing why designing an IoT system is so important. So, guys, while building any application, let it be a computer-oriented application or any real-time application, what we do is we guys try to put more time on its planning actually. So planning is nothing but in your IoT domain, we'll put more time on its design actually. So for understanding purpose, what we do is we'll try to stick with our IoT system only. Now guys, you must be knowing its several application. So its means your session is started from Monday. So by this time you people have got to know what are its application, right? Now if you consider any IoT application, let it be home automation system or smart irrigation or any healthcare system where we are applying IoT system. Now guys, just try to look what are components are involved in such IoT system. So there will be an IoT device, there will be a network that is required to connect your IoT device. In addition to that, since a human interaction is required with an physical entity, there must be some interface between such IoT devices actually. Now guys, since there are various components are involved in your IoT system, it's very challenging to design any IoT application actually. Why it is? Why it is so is it needs to have an interaction with whatever IoT devices are there. For that purpose, we can consider any application actually. So we can consider this room. Now I want to automate whatever lights are there in this particular room. For that, what I need to do is I need to connect these physically available lights to the internet actually, so that a room attendant can manage those lights or fan, whatever things are available in this room through its mobile actually. It might be in web form or it might be in any app actually. Now, now here we are going to see what is so important to put a more effort on IoT designs actually, IoT design methodology. Now, for understanding purpose, you guys consider any application. Let's say one of you owns a company. Now you got one application to be built for some XYZ client actually. Now there in your company you formed a member of 5 members and asked them to work on your client's project. So, if you in that case, what will be there is a company will be having the whole idea about what application is supposed to be built by your team. Now, as a team, as a company owner, if you ask the respective team to directly build an application, in that case, what happens? There will be a monopoly of employees who are working on that particular application design actually, who are working on building that particular application. So it's like if those employees who are involved in building that particular application leaves the organization after developing that particular app, what happens? As a company owner, I won't be having any idea how they have built an application. So to reduce that dependency between employee and employer, we must have design methodology about any application actually. So design methodology tells about the clear picture of building any application. It won't be specific to any particular application. It gives you a clear idea about any real-time project. So here with this topic, we'll try to understand what design methodology need to be followed when we are designing an IoT system actually. So here I refer one of very popular book in IoT. You guys must be knowing Internet of Things, hands-on approach. So it's written by I think Bahal and Medi Shetty actually. So those are the authors. They have written a very good book that is named by Internet of Things, a hands-on approach. So if you get time, just refer that book. There you will find the very clear detail about each and every aspects involved in designing any IoT system guys. So here we'll be focusing more on how an IoT system need to be designed. So here in any IoT design methodology we need to follow 10 steps of procedure actually. So here we are going to go each of those steps to understand how a IoT design system need to be prepared actually. So here what you can see is the very first step of IoT design methodology is purpose and requirement specification. So this is the very first step in developing any IoT system actually. So if you follow design methodology for building any application, as I said, there won't be any dependency between employee and employer. And in future, let's suppose you want to add any new features to your IoT system, we must know in which part of my application that particular new features has to be added. So when you will get that understanding, when you have a design of that particular IoT system in your hand. So guys, let's start knowing from each step of a IoT design methodology. So For understanding purpose, we can generalize what are steps involved in your IoT design methodology. I will be going through each of those methods in details so that we'll have a clear picture about any IoT system actually. So for understanding purpose, we'll consider one case study, and with that case study, we'll try to figure out how those different steps of a design methodology help you, give you a clear idea about designing any IoT system. So the very first is purpose and requirement specification. So in this step, what we do is we define the purpose of designing an IoT system. In addition to that, we'll have the clear user requirement from our client actually. So here in this step, what you do is so in this first step, what you do is the purpose, behavior, and requirements of the IoT system we are going to build are captured actually. So in purpose, what you do is we figure out what is the purpose of designing a given IoT system. So for understanding purpose, let's consider this room itself. Now I want to automate lighting appliances that is available in this particular room actually. So here my purpose will be to automate light appliances that is available in this particular room. So this is my main motive behind designing an IoT system for this room. Now I figured out what is the purpose of the IoT I am going to design for this room. Now we need to set up the very next thing. We need to get clear out from our client what behavior of IoT you want to imply actually. So in behavior, behavior of a given IoT application, what I do is I will tell as a client I want two features to be added for this lighting. One is manual mode and another is auto mode. So what this manual mode says? Manual mode says here your room attender, if he wants to on light or off the light which are currently in a on state, that can be managed through any app actually. So in a manual mode, I am expecting there should be an app that lets me turn on the lights that is available in this particular room. That will happen through your manual mode. So the behavior I want for this for this IoT system is the very first one is manual mode, where whoever room attender is there, he should have access to control the light system remotely. He should not have to come to this particular room and use the whatever traditional switches are there to on and off your lights actually. And the another mode that I want is auto mode actually. So in auto mode, what happens? There won't be any human involvement actually. So it's like I don't want any person to look after whether to turn on or turn off the light that is present in this particular room. So if that feature has to be added with your IoT system, what is required? We must have some sensor put it on my devices so that it will keep sensing the light level in this particular room. Now for that we'll set up some threshold. If the light level of this particular room falls below the whatever threshold you guys have set up, then my IoT system should turn on the light. So here in another behavior of my automated system, what I want, there must be a feature that take care of lighting on and off based upon the light level present in this particular room. So the viewer for a given application will be decided in your first step. Now the 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 third important step, the third important step that is available in your first step itself is requirement gathering. So here in requirement, what you do is we'll take a clear picture from your client. So here we'll be having a data collection requirement. The very first step in a requirement is data collection requirement. There we ask our client how a data need to be collected, in a what form. So here in data requirement specification, the client has to specify how the collected data has to be stored, whether it has to be stored on the computational platform that will be there with your sensor node, or if your application is going to generate a more data, in that case it's supposed to be stored on some third party cloud storage actually. So that will be cleared in your very first requirement, that is your. So here, so here in your requirement, the very first thing is to decide data collection requirement and how it needs to be stored. The second one will be data managing data specification actually. How the data need to be managed. Now whatever data you guys have collected, that need to be analyzed to perform some action actually. So here, with respect to our application that is automating our light appliances that is available in this particular room, the data will be the light level that is present in this particular room actually. So that will be continuously captured by your IoT devices. Whatever sensor will be putting in your IoT devices, its objective is to collect the light level continuously. Now if light level falls below the whatever threshold you have set, in that case it's supposed to be turn on the light. So here in a managing data requirement, what you specify is how a data need to be managed, whether at locally at sensor itself, or you need any cloud services to to manage and analyze your data actually. Now after that, it's moving here itself. So after that, we need to work on system management requirement actually. So what are things are required to manage your system, means whatever IoT system that you are going to design, what things are required to manage it. So let's say in any IoT system there will be an application server that gives you, means that process the data and gives you what result is what data is asked by user. For that we need an application server. To store that data at device or the cloud, there will be a database server. To interact with user and actual application server, we need a web server actually. So here, how this server that are involved in my IoT system, let's say web server, application server where my data is being processed, and the database server which has my data stored on it. So how those different server that involved in my IoT system need to be managed has to be fixed out in system management requirement specification actually. So it's like for any IoT system, what you do is in web server we mostly use REST API to interact with user and get results from its server actually. For application server, again you can use a REST API, and for database server you can use either MySQL or MongoDB or the light version of REST API itself. Now at last, in your requirement specification, we have to tell how you are going to provide a privacy to your data, and how an user is going to access your system actually. That has to be fixed out in a data privacy and system. Can you just continue? Why did changing that one to be? So here in data privacy and security requirement, we need to specify how you are going to provide, means how you are going to keep your data secured, and who are the users for my IoT system actually. So here a basic level of authentication and authorization will be provided. For that, as a client, we need to give all details about who are going to use my system and how their they are going to be authorized on my database. So that will be decided in your data privacy and security requirement actually. So in a first step, that is purpose and requirement specification, what will be there? There will be three important things are going to be captured. The very first one is the purpose, why you want to automate your physical devices. Beware, we need to tell what are the functionality will be there on my IoT devices, and in requirements we have to give the clear-cut requirement for your system that you are going to build. So whatever requirement that are there here is similar to your software engineer topic, that is a design step will be there in your software engineering topic, right? So there also the very first step is requirement, user requirement. The same thing is also applied here in your IoT as well. Now, once you have a clear-cut picture about your IoT system, what purpose of IoT system you are going to build, the next thing is process specification. So here, in a second step, what we do is we define the structure of whatever user requirements that is given by previous step. So here, what you do, we'll use a graphical notation to specify what process, means what are the process will be there in my IoT application. Now, since we are considering automating our light appliances available in this particular room, what you do is in this process specification step, whatever requirement gathering we have collected from previous state, we simply formulate those requirement into a use case diagram or process diagram. So you guys must have learned use case diagram in your software engineering. So same thing will be used here to give us a graphical representation of my functioning, which will be there in an IoT application. Now, for understanding purpose, what I will do here is I will show you how a process diagram or use case diagram look alike for automating light appliance actually. So in a previous step, we fixed out the behavior of our IoT system. That is, there should be two modes. One is the manual mode and another is the auto mode. Now, to have a use case diagram about my IoT system, we start with your circle actually. So when you try to recall your software engineering knowledge about use case diagram, your flow chart start from circle. Then with rectangle box, we can specify the state of your use case diagram. So here my state will be, mode, and I will use a, so I think I should start from top of the white box. So that is good. So as you know, the use case diagram start from circle representation. Then in our previous step of behavior, we set up that there should be two kind of mode available for my system. So for that, to specify a state, what representation we use a rectangle box. So with rectangle box, we specify the state of my IoT application. So what we want two functionings to be added to my IoT system. So for that, to specify which mode is on in my application, we need to decide using a decision box. For that, what we use a diamond box actually. So with the help of diamond box, we'll apply a condition to specify which mode is currently on actually. So there are two modes that is required for my automating light appliances. The very first one is manual mode, and the second one is auto mode. Now if my state is manual mode, now what we have to do is we have to allow a room attender to turn on and turn off lights actually. Now here what we have to decide based upon the light level present in the given room. Now here what will be there? There will be a decision box. So that decision box is working on light level. If light level is low, if, if light level is low, then it should turn on the state of light, that is the state of light will be now on. Similarly, if light level falls above the threshold, if light level is high, then we have to turn off the light actually. Oh, sorry, so in manual mode we don't check the, it's a manual mode. So in manual mode we don't check the room light actually, so that's supposed to be checked in auto mode. So I did one mistake here. So in manual mode there will be human interaction, so we don't have to check the level of light present in room. So that has to be decided in auto mode. So in manual mode what happens? So basically in manual mode, irrespective of what level of light is there in my room, the complete control will be given to whoever attending this particular room actually. So here in a decision box what will be there? A state will be there. So this state tells what is the current state of light. If it is on, let's say if it is on, and user asks us to off it, means if user gives. So here let's say I'm having a user interaction. Let's say I'm having a user interaction here. So its input is on, its input is off, then in that case it's supposed to be, so this light supposed to be off actually. And if user input is so here it's already on, right? So this is what one state has to be done here. Similarly, if it is off and user wants to turn off that light based upon its input, based upon that input, in that case this state of light should be on actually. So this is what a graphical representation will have in case of designing an IoT system for atomizing our light appliances actually. So with this use case diagram, what we will get is, we will get an understanding about what are functions needed to be applied while developing my IoT system actually. So looking at this graphical diagram, we'll have a clear-cut idea about what function has to be added in my IoT system and how it needs to be added. So looking at this diagram, we'll clearly get to know that there must be two modes created in, I mean built on my IoT system. One and those mode are, one is manual mode and another is auto mode. If it is auto mode, then we need a sensor to sense the light level in my room. If it is manual mode, in that case you, your IT system should check what user input you are going to get. So that idea will get clearly when you have a use case diagram in your hand. So here in a second step, what we do is we use a use case diagram based upon whatever requirements we received in a first step. So guys, for process specification, what happens, we specify the process of our IoT system actually. So it won't be specific to any particular IoT design actually. So here, since we are designing automating our light system, it won't be specific to that particular example. So whatever step that I am teaching here will be applied to designing any IoT application actually. So here, in a domain model specification, what happens? What we do is we define the concepts, objects, and entities based upon previous two steps actually. So here, in a domain model, we generally describe what is concept of a IoT system, then what are entities are required for designing my IoT system, and for that, for each entity there will be some set of objects in my IoT system, and how those entities and objects are related with each other so that our functioning of IoT systems are clearly specified. So here, with the help of domain model, what happens? We clearly specify what are entities are involved in my IoT applications and how those entities are related to each other. For that, what happens in a domain model specification? We try to mimic the physical entity that is present in my application into digital world actually. So here in a domain model specification, what we are trying to do, we are trying to digitalize whatever physical entities that are there in my IoT system, and we'll convert its digital replica actually. So here, the very first component that need to be modeled in your third step, that is domain model specification, is physical entity. So physical entity is the first entity that has to be modeled in my first step. So here physical entity is nothing but any physical thing actually. So in our example, let's consider with our example itself. So since we are considering automating our light thing, here the physical thing will be, the physical entity will be room. So we have room, and the second is light. We have those two physical entities involved in my IoT application actually. So with these two physical entities, we'll have a complete understanding about my application that I'm going to automate. Now once we decided what are the physical entities are going to be in my IoT system, the second step is to create the virtual entity of a physical entity. Why do we need to create virtual entity? We need to create virtual entity to represent our physical entity in a digital world actually. I mean, whatever app or web page you are going to develop for your IoT application, for that whatever physical objects that we will be considering for our IoT application has to be represented in a digital form, so that with our app or web page we can communicate or we can assign some tasks on it actually. So here in our automatic light appliance example, what you do is we'll create a digital version of room and light. Why this virtual entity is required, we'll see in a later stage. Now once we fix out physical entity and virtual entity, the next thing that need to be modeled is device. So device is required to interact between your physical entity and virtual entity. So here what we want as a device to connect your to establish a connection between physical entity and virtual entity is sensor actually. So with the help of sensors, what we do, we collect the light level present in this particular room, means the physical room where we are embedding our sensor. With that, what we will get the level of light present in this particular room actually. And we pass that information to the our whatever database server we are going to use. It means here this sensor is going to act as interaction between your physical and virtual entities. So by any chance, does anyone know which sensor is required to see the level of light present in my room? You might to you might to got to know about basic sensor types in first or second lectures, right? What are those sensors which help me to get the light level? Do you have any idea about it? See, we need a sensor for automating my light. So now the next important thing as a IoT developer is to figure out which sensor is required. Any idea? So here we need LDR sensor. So LDR sensor is a light dependent resistor sensor actually. So LDR sensor has a dedicated task to check the light level present in whatever device you will be using actually. So here I'll be using on top of my light. So here the job of LDR is to check the light level present. Now with the help of sensor, you got to know what level of light is there in my room. Now you have all the information. Now you get to know there is low light in a given room. Now I want to turn my light automatically. For that purpose, what is required? We must have actuator. So what actuator does? It it performs action actually. If you are going to see a very simple meaning about actuator. So here we need an actuator to turn on my light actually. Means to turn on or off, I need an actuator. In a given case or in a given application that we are going to automate, we need electronic relay switch. So the role of electronic relay switch is to take a signal from your signal and act upon it. If it is says to on, then that relay switch will perform an action of opening. If you ask to turn off the light, it will simply turn down whatever node will be present in your electronic relay switch actually. It will be called relay electronic or electronic switch. So it's like I need an actuator called as electronic relay switch. So what it does is it helps us to perform the main action of turning on and off my light appliances. Now once you model the devices, the next thing is resources. So resource is nothing but a software component that is required for your IoT system to be automated. So in my given case, I will be using a Raspberry Pi kit. So here I need to install some Linux OS that supports on my Raspberry Pi toolkit actually. So here the resource is nothing but a software component. So here I will be using Raspberry Pi OS. So with this OS I can interact with my database as well as a user who are interacting through any app or web page actually. And finally, I need to model services of a given IoT device actually. In services, what I have to specify as a IoT developer, I need to specify what are services need to be modeled for a given application. So in case of our automating light appliances example, the very first service that need to be applied is to check what mode is on as of now. So whether it is auto mode or manual mode, for that I need a service to get that information actually. So with the help of REST APIs, by using get REST APIs, I will get that information from my database server. Similarly, so if the mode is auto or manual, again in each of those mode, I need a separate services to work on that particular mode actually. If manual mode is there, then the service APIs has to interact with an user's input. If user input is to turn on a light, in that case the service API supposed to check a job from client, and means the service API job is to take an input from user and send that input to my activator actually. And similarly, I need a one more service in another form of mode actually. So that is auto mode. In auto mode, based upon whatever light level is there in my room, whatever sensor gives me a signal, the service API whatever REST based service API I am going to use, that has to be performed. So basically, for a given application, I need three services actually. One is to check the mode. Second is to work on manual mode, and the third service is to work on auto mode. So here in a domain model specification, all five five components will be clearly defined by specifying their relation between. So once you have a domain model specification clearly defined, what you do is we'll add an attribute to the virtual entities that is figured out in a previous state actually. So here in an information model specification, what you do, we structurize the virtual entity that we have previously defined. So here in information model specification, what happens exactly is we are trying to mimic the virtual entities over digital platform actually. For that, in this particular step, what happens? The relation between attributes and entities are defined clearly actually. So here, in a previous state, we got to know that there are two virtual entities required for my light appliances, and those two virtual entities, that is room and light, what are attributes need to be specified for those two virtual entities are fixed out in this particular step. It means what it means, it shows what attributes need to be passed for my virtual entity when we are trying to write down its actual code actually. So it simply specifies, let's say I want to calculate the average marks of a student. In that case, what attributes will be there? That the main attribute will be its score actually, means scoring each of those subjects that is offered in that particular semester actually. Similarly, here in this information model specification, same things happen. So it tells what are attributes required to completely virtualize the virtual entity we are fixed out in a previous step, that is domain model specification. So here in case of our light example, what will happen in an information model specification, we specify the number of attributes required for room and light. So in case of room, I need an attribute. So in case of light, I just need one attribute, that is the light level actually. So this light level tells me what level of light is present in my room. You just need one attribute for room actually. Similarly, for the another virtual entity, that is light, for that I just need one attribute, that is state. So with the help of this state attribute, I will get to know the state of light, whether it is on or off. So here in the information model specification, what happens? We specify what are attributes that is required to represent your virtual entity in a digital platform. So here, fifth step, what you do, we specify what are services need to be provided for your IoT application that you are going to design actually. So here the services are related from how a input output has to be act, then it also has the services related to how my work is going to be scheduled. It has a services related to check whether there will be any conditions, preconditions has to be checked before before activating my activators. In addition to that, the main services of any IoT system is how it need to be worked actually. So here, in case of our light appliance, there will be only three services actually. The services that I had discussed in case of data model specification, the same services will apply for our light appliances example actually. So it's like in a service specification, we'll be specifying all the services that has to be provided by your IoT system. In case of light example, as I said earlier, you need to first figure out the mode of light appliance actually. So it can be manual or auto mode. So if it is manual mode, so the REST APIs, there will be two REST APIs are required based upon each mode actually. So REST API job is to check the level of light present in my room. In case of auto mode, REST API used to check light mode, light level actually, light level in auto mode. So in your manual mode, so another REST API is used to check user input actually, check user input in manual mode. So these are three main services that need to be specified in addition to input output services and system management services actually. Now here, this is again another important specification. So with the help of IoT level specification, what you will get to know is how you are going to, to club all those IoT devices actually. So here in IoT, around there are around six, not exactly six actually. In some book it is referred six levels of IoT deployment, and in some book it is referred four to five levels of IoT deployment actually. So what this level tells is how we are connecting our IoT devices with network and where we are performing the analysis of data and its processing actually. So here, in case of our in case of our light example, light appliances example, how we'll be connecting our devices is, so we'll be connecting our sensors embedded on light, and whatever light level will be there, we are going to take its decision on given sensor node itself actually. It means we are trying to keep a data at local node itself actually. So it's like in a level 1 of IoT, so in a level 1 IoT, what happens, there will be a single IoT device that collects a data and process it on same device itself. So such level of deployment is called as level 1 IoT deployment actually. So there will be again 4 to 5 another levels based upon how we are collecting the data and performing its operation actually. So here in a level 2 of IoT deployment, so in a level 2 what happens? There will be a single IoT device. So here also in level 1 also there will be single IoT device actually. And the data collections means data collection and its processing happens at same level actually, happens locally actually, locally at same device. So whereas in a level 2 level 2 of IoT deployment, what happens? There will be a large number of data generation actually. So in that case, whatever IoT devices you guys are using won't be having enough space to store the recurrently generating data. So for that purpose, we can consider an example of, let's say, smart irrigation. So in a smart irrigation project, there will be having multiple sensors used on our agri land, and it will continuously generate the moisture level of my sand actually. So, so whatever data that is generated can be occupied at your IoT device, means whatever Raspberry Pi or Arduino tool you guys are going to use, it won't be having enough space to hold that data. So in that case, what is required? We required some cloud services to store my data actually. So here in the level 2 of IoT design, what it says, when we have a single IoT device and for storing purpose, for data storing purpose, storing a data at cloud actually. For data storing purpose, we have to use a third party storage. Then such level of IoT deployment is called as level 2 IoT devices. So where the data can't be stored at locally on your Raspberry Pi toolkit or a Arduino toolkit actually. So when you have a such physical limit where we want to use a third party services for a single device, then such level of deployment is called as level 2 deployment actually. So in level 3 of IoT deployment, what happens? So here I forgot to tell you one thing here. So data can be stored at third party cloud actually, but its result can be captured at locally. Means whatever toolkit you guys are going to use, it will be analyzed at local device itself. It means it has a computational power, but not enough storage actually. So the same thing happens with your matrix multiplication program actually. So let's say you are going to do a matrix multiplication of 1000 by 1000 matrices, and in that case, let's say if you are using a three 2D arrays, what happens? You simply throw a segmentation fault error, not exactly segmentation fault error. It throws stack overflow errors actually. Means whatever local variables we declare in our program allocates memory at stack memory, right? So stack memory is about 8 GB actually. So here, when so you know that your CPU is able to perform a matrix multiplication of 1000 by 1000 matrices, but when you create a 2D array of 1000 by 1000, it won't occupy that size of data in your memory, because for local variables it takes a memory from your stack, and stack has a default memory limit that is 8 MB. So here, in case of 1000 by 1000 matrices, what happens? We need uh, more than 8 byte of memory actually. That won't be occupied in your stack memory. But your CPU has ability to perform 1000 by 1000 matrices multiplication. So what problem we are causing there? We are causing a problem of stack memory overflow. If you want that same multiplication to be done, what we do? We use a malloc and we try to allocate those two arrays on a heap memory actually. So heap memory is again equivalent to your RAM size. So since we'll be having a RAM size of at least 4 GB or 8 GB, we can easily occupy 3000 by 1000 matrices easily. The same thing happens in level 2 actually. So level 2, what it does, it takes a, a help of cloud to store its data, but it uses a computational platform of its own. So here in the level 3, in level 3 of IoT deployment, what changes has been made to the level 2 is the computation will also be performed at cloud itself actually. So computation of data will be performed at cloud itself. So after performing an operation at cloud, so whatever action has to be performed will be similar to your activators actually. So here data analysis is performed at cloud actually. Whatever cloud services will be using, it will be performed at cloud services. So here in a level 4, what difference will be there? In a level 4, we allow multiple IoT devices to be connected together. It means, so here till level 3 we are discussing about only one IoT services, that is uh, very specific actually. So here we are so one of IoT devices here will be a light. Automating its light will be one IoT service. Now in level 4 what happens, we combine such multiple IoT devices together. So here let's suppose in same room, let's say I have a washing machine that also has to be automated. It means what we are doing is we are combining two separate IoT devices together. So when you have such a deployment, it falls under level 4 actually. So in a level 4 we have multiple IoT devices. Now looking at all those four level of IoT deployment, we can easily specify what IoT level our at, automatic light appliances fall under. So you just need uh, a single IoT device, and its data is also collected locally and perform its action on that toolkit itself. We don't need a third party cloud services for a light appliances actually. So here our here the level specification that is required for my IoT system is level 1 actually. So when you have the level of deployment clearly specified in your design process itself, then you will have a clear understanding actually. Let's suppose I want to do some changes in my IoT system, or I want to add some features. In that case, the whoever new employee will be there in organization, he does not have to look about cloud services actually, because just looking at this IoT level of specification, you will get to know that for this particular IoT system development, we haven't used any cloud services. So we'll get that insight when you have a clear IoT specification designed for your applications development. So with the help of IoT level specification, we'll know what are different levels are involved in my IoT systems design actually. Now here in a functional view specification, what happens? So whatever functionalities are there with respect to your IoT application are combined together actually. So here what happens? The grouping of functionalities happens actually. So here whatever functionalities are there, whatever different functionalities are there with respect to your IoT applications are grouped together. So there are various group of functionalities that will be there for any IoT system actually. The very first or the very low level of functional group will be your device. So the very low level of function group will be device. The upper level of function group will be application. So in it, what will be there? We'll be having a communication group. Then we'll be having a services group. So then we'll be having, it's like security and management actually. So it's like security and management. So we'll be having at least 6 functional group with respect to any IoT application actually. So each of these group tells what are functionality of respective functional groups actually. So here in device it tells which device are required to connect physically with my sensors actually. So here you can use either Ethernet, you can either use Ethernet or Wi-Fi or your cellular devices to get connected with your device, whichever devices you will be using for your applications actually. So whichever toolkit you will be using. So with this functional group device, it tells what medium is required to communicate with your toolkit. So you guys must have learned what falls under device category actually. Sorry, so it's device, right? Yeah, so here what devices are required, that will be specified actually. So here, so next we'll be having a communication. So communication functional group. In a communication functional group, we'll be having the whole communication protocols in your hand. So it's like in a link layer, what protocol has to be used? So can I use Ethernet? Can I use, that is for Ethernet we use ethernet 2.3 protocol actually. Ethernet 2.3 is used for ethernet 2.3 for used for your Ethernet. You can use ethernet 2.11 for your Wi-Fi. Similarly, ethernet 2.16 will be used for your WiMAX actually. So we need to specify which link layer protocol has to be used in this functional group. Similarly, network layer, we need to specify whether you are going to use IP IP version 4 or IP version 6 IP protocol, that you need to specify. Then in your transport protocol you need to specify, are you going to use TCP services or UDP services. In application layer protocol you need to specify whether you are going to use, what is that, REST API or HTTP API or XAMPP or MQTT. All those application related protocol has to be specified in this particular communication functional group. Similarly, in services, whatever 3 services that we had discussed in case of service specification has to be used. So in a management functional group, we need to specify how your web services has to be managed, how your database server has to be managed. All those things will be specified in a management group. In an application group, you need to specify what application are you going to provide for users interactions. It can be web service or any API, third party APIs. So that will be decided in your functional view specification. So whatever we figured out in a functional view specification, in operational view specification, what you do is we provide how means basically in operational view specification we provide what particular protocol or medium you are going to be used for this functional group we have specified here. So once we specify the operation of specific functional group, the last task is to integrate device and components that we have designed in our use case diagram and in our information model actually. And finally, we'll be having application development actually. So here in application development, what you do? So let's say we are providing a a web page as a user interface. In that case, we develop all these service APIs using either REST APIs or using socket programming. We define the interaction between the whatever IoT devices that presents with your end user actually. So now we can quickly see the home automation case study with respect to whatever design methodologies we have seen. So here, in a very first step, that is purpose and requirements. What you do is we specify what is the purpose of home automation system, then what are its behavior, and then the requirement analysis will be clearly shown. So here in a process specification, as I said earlier, process specification gives you a use case diagram about your IoT system that we will be designing. So here what you can see is we have a use case diagram in our hand that gives you a graphical representation of your IoT system. So here in a home automation system, what you can see is, again, in a home automation system, what we automate mostly is our light services only. Our light appliances we try to automate. So the same example is also there here. So here in a process specification we will have a graphical representation of what process our home automation system is going to perform graphically. So in domain model specification, whatever components that I talked about is presented for your home automation system actually. So here we can see that we'll be having a user interaction. So your user, what it does is it will talk with your app that we will design to interact. So from that app we'll get an action. So that action is nothing but its services actually. So from that app you'll get a services, and that services will be applied on virtual entity actually. So those services are connected with virtual entity. So as I said earlier, virtual entity represents the actual physical entities actually. So in case of our room example, there are two physical entities were there. Now here in this diagram you can see that we have two physical entities. One is the room and another is light actually. And so here resources, as I said, resources are nothing but your software component. From here the action will be performed, and here the respective action will be passed to the activator actually. So here here the sensors and actuators are connected with your device. So based upon what action has to be performed, it will be notified either to activator, or if you want to sense that particular data, a sensor will play a role on it actually. Now here in information model specification, as I said earlier, in information model specification what happens? We specify the attributes to the virtual entity. So here in a home automation example, there are two virtual entities, that is room and light. So here you can see that their attributes for room and lights are defined with their with their state actually, with their values. So what values has to be initialized for my attributes are clearly defined in information model specification step. Now, once you have a clear idea about graphical representation for your IoT system, the next very important thing about any IoT system is to have service specification clearly defined. In a service specification, what happens is the action supposed to be taken by IoT devices are presented actually. So here, in case of your home automation system, what we are doing is we are trying to mimic the light to be managed automatically actually, and give signal to turn it on and off. So you can see that here what we did is the use case diagram, I mean the process specification and the information model specification are combined together to generate its services actually. It means when you get these specification and information specification clearly, you don't have to keep thinking about its what services has to be generated for your IoT application actually. When you get process specification and information model ready with you, you can easily generate service specification out of it. Now here in a service specification, as I told, there are three services possible with your light appliances. The very first one is to figure out whether my state is whether means what mode is on actually, whether it is a manual mode, whether it is manual mode or a auto mode. If it is manual mode, then you have to check the user input whether check the user input in case of manual mode, and in case of your auto mode you have to check the light levels present in a given room. Similarly, so as I talked earlier about IoT level specification, so looking at this particular diagram, what you can see is there is no state present in a cloud. It means you are not taking a help of cloud services to design my IoT system actually. So it means my level of IoT deployment is 1. So here in a functional view specification, I already talked about all six uh, all six so here in a functional view specification, I talked about all 6 functional group based upon their functionality actually. So here in a devices, as I said earlier, what are devices are required for your IoT devices are fixed out actually. So that for any IoT application, we must have at least 2 devices. One is the sensor and another is the actuator. So you must be knowing the role of sensor is to sense what is happening on your system. If anything changes happen, you need to inform it to your computational device. So that is what job of your sensor. So whatever changes it records, it will be forwarded to your actuator. So actuator perform action based upon what is being sensed actually. So similarly, so whatever 6 group that I mentioned here are there actually. So the same thing is there for your automatic home system as well actually. So I will skip this thing. So here in operational view specification, what you can see is you can clearly see that in a device what I am going to use. So here you can see that for automating light appliances or any home system, what we need a computing device. So here we can use a Raspberry Pi, or you can go ahead with the Arduino toolkit also. In a sensor, as I said earlier, to sense the light level in any room, we must have LDR sensor actually. Now to switch on and off your lights, you must have electronic relay switch actually as an your actuator. So that will be fixed out in your operational view specification. Now similarly, in a communication model, you need to specify what are protocols you guys are going to use in all 4 layers of your communication model actually. Now similarly in a management, what you can see is if you want to manage the database, what need to be used. So in a given case, you can use a MySQL database management tool to manage your database related services actually. So here, to manage the actual services of any IoT devices, you can go ahead with your REST APIs. You can use REST APIs for web services, and for the normal actuation purpose, you can go ahead with native services actually. So with the help of controller, whatever controller you will be using, with that you can manage that. And finally, in application functional group, what we do is we specify what operation has to be performed in a application actually. So here you can see that we need at least a web app so that an user can interact with that particular web app and give its input actually. So application server and database servers are required. So application server is basically required to take to process the data, and the database servers gives the respective data that is gathered by your sensors actually. So this is the device that is required for your automating the light appliances actually. So here what you can see is we have a Raspberry Pi toolkit connected with actuator and sensor actually, LDR sensor. So here we will have the application development. So here what you can see is we have a dashboard. Through this dashboard, we can means a user can select either auto mode or the light mode. So light mode is nothing but the manual mode actually. So if you want a light to be turned on remotely without being in this particular room, in that case what you have to do is you have to simply use a light mode selected actually. This light mode need to be selected, and if you want a light to be turned on based upon the level of light present in room, for that you have to select the auto edge. So here, this application, for developing this particular application, you can use the web services, means REST API services, or else you can simply build an app through which you can interact with your IoT devices. So guys, this is all about design and development of IoT devices. So if you have any question, doubt, you can ask. So if there is no question, no doubt, I will stop here. Thank you.
Thank you, sir, for sharing your knowledge. We appreciate all the valuable insight you have provided.
I would like to request Professor Sunil Hebbade sir to present the memento to our resource person, Dr. Pramod Elmeva.
Now I request everyone to follow for small tea break. After the tea break, I request every faculty participants to gather near college entrance for group photo session. Both faculty and student participants. After the photo session, the second session will be start. I request every participants to follow for photo session. After that, the tea break will be conducted.
Everyone is informed to gather near college entrance. Everyone should gather in front of college.
Hmm.
A pleasant afternoon to one and all present over here. I take the immense pleasure to introduce our resource person, Dr. Prakash Pawar. Sir is currently an assistant professor at Indian Institute of Information Technology, Dharwad, specializing in electronics and communication engineering. With over 5 years of teaching and research experience, his focus lies in the development of embedded applications and IoT for intelligent energy management systems. Sir's technical expertise spans areas such as embedded system design, IoT application, FPGA prototyping, VLSI design, artificial intelligence, machine learning, and optimization. Sir earned his PhD from NITK Surathkal, where his research involved the development of advanced smart energy management frameworks integrated with optimization techniques and prediction models for demand-side consumers utilizing IoT platforms. Dr. Pawar has published in reputable journals such as Elsevier and InterScience, showcasing his contributions to the field. Aside from his academic pursuits, he has actively participated in international conferences, presenting papers on topics like data acquisition, IoT-enabled weather monitoring, and smart waste management systems. Dr. Pawar is also a member of the IEEE. In his role at IIIT Dharwad, he has been involved in various academic and administrative activities, serving as chairman of a career guidance cell committee, organizing summer training programs, and acting as a faculty advisor for undergraduate students. Dr. Pawar has also initiated collaborations with international institutions, fostering research and internship opportunities. His commitment to education and research is evident through his diverse skill set and extensive contributions to the academic community. It's an honor to have you among us, sir. Thank you.
Thank you, Sakshi. I request Dr. Bahubali Akiwate sir to welcome Dr. Prakash Pawar, Triple IT Dharwad. Thank you, sir. Today, to enlighten us about IoT system design and development, we would like to invite Dr. Prakash Pawar.
Hello. 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 Check. Thank you. Thank you for your kind words and welcome you. Yeah. For the today's session, I'll be discussing about the case studies and future trends in IoT domain. So, yeah, it's working now. So, coming to the outline of the session, so I'll be discussing about a simple example how IoT device works, then the state of IoT as of 2023 census, like where it actually stands in the global IoT market, then the different case studies. So in particular, I'll be taking up case studies on the industrial IoT related to the the monitoring and the manufacturing related operations, and then uh, the next case study will be on the IoT agriculture related part, and subsequent to that the case study related to the healthcare domain, okay, and also some of the case studies related to the smart cities also will be included in this session. So once we're done with this case study, I have some videos to uh, like some of the videos to demonstrate for the demonstration. Like before we move on to the trends on the IoT session part. So in the trends on the IoT session part, we'll be discussing in particular about the role of the artificial intelligence in IoT domain, like what is the trend, with the integration of AI in with IoT, and like moving further, we'll be discussing about the role of edge computing, the trend of the edge computing in the AI domain, and then again, what is the futuristic proposals in the healthcare domain related to the IoT, and again similarly in case of smart cities, and also like with integration of blockchain, what is the trend in the IoT domain, and like with the recent development of a voice activated device, like how is the trend in the IoT device, and what is the market perspective, and later on we'll be discussing about the challenges of implementing IoT as well, like a couple of slides on that. Okay, so to start with, yeah, so you must be aware like how IoT works. So we have the end devices where it could be any sensor node, you can say, for that matter. So it could be related to the activity detection, or it could be related to the temperature monitoring, or it could be related to the blood pressure. So the data from the end device will be sent to the gateway. From the gateway, the data will be sent to the cloud or the server. Okay. So this is the usual trend that happens with every IoT related device. So once the data is sent to the cloud, then we can say the device is connected to the internet. Or once the data is being sent to the cloud, the user can access the data from anywhere he wants. So that accessing the data remotely is possible once the data is fed into the cloud. So for example, like you have the your mobile phone where you can actually, if you install some of the app related to related to the fitness, so the activity will be like monitored and stored in your mobile phone. Okay, and then the again your mobile itself will act as a, like there are sensors involved, there are a number of sensors involved in your mobile phone. So it has some of the sensors, and your mobile phone itself will act as a gateway there, and the data will be sent to the cloud from the mobile phone itself, and that data can be accessed from anywhere you want. Okay, again it depends on the app you are using, or depends on the subscription that you are availing. Okay, so similarly, if you are going for any the weather forecasting related data, or any the healthcare related applications, so there you will have the sensor device or the end device. So one thing that is mandatory or that is required is the mode of communication. So the sensor device or the end device should be capable of communicating with the gateway. That is, again, it depends on the local area network or wide area network, or the home area network. So depending on the range of communication, that will be like it can be decided. It is up to the designer's choice, or depending on the domain of application. So once the communication capability possessed by the IoT device, then the data can be sent to the gateway, and from gateway to the cloud. And once the data is being stored in the cloud, so it can be accessed from anywhere it wants. So that is the main like that is how the IoT devices work. So it holds true with all the other IoT devices we'll be discussing in our sessions today. So it will have the sensor along with the communication capability, along with the computational capability, depending on the again domain of application. And whenever we are discussing about the IoT use cases, the domain of application is very useful. A particular application, a particular use case, for that particular use case, what is what are the constraints involved and in which domain that is being used. That is very important with a designer's perspective. So, if you are planning to design any IoT based applications, first you have to check what are the constraints involved, okay, and like what is the domain of application. So in the healthcare domain, what are the major concerns involved? In the domains related to like if it is a entertainment related application, what are the concerns involved there? So concerns could be anything. It could be related to the size of the device. It could be related to the power consumption of the device. It could be related to the cost of the device. It could be related to the resource utilization of the device. So that is very important when you are trying to decide the IoT based applications. Okay, and so yeah, so this is the usual trend how IoT devices work. So now coming to the this report is from the IoT analytics like company, where there is a the forecast for the global market where IoT exactly stands, and you can see that from 2015 to 2022 there is the actual data involved, the actual data like how there is a demand for the different IoT devices that are being involved, and you can see the different connectivity type that is being involved here. So again, depend on the communication that is required. It could be local area network, it could be home area network, or it could be wide area network, depending on the range of communication. So when it comes to the IoT devices, the range of communication is one of the important criteria that needs to be selected or that needs to be decided. So we can see that in the trend, the cumulative annual growth rate here from 2015 to 2022, these are the actual facts where you can see the growth of the IoT devices in the market. So every year we can see from 2015 to till 2022. So there is like almost 23% growth in the market rate of the IoT enabled devices, whereas again there is slightly decline in the rate of growth of the IoT devices, but still it has a significant growth in the market. So, but in this duration, we can see there was, I mean, very they were emerging in the market, and there was a very good hype for the IoT devices, and like most of the users are most of the like they have the curiosity to use the IoT enabled devices, or most of the manufacturers they were very curious to bring new IoT enabled devices into market, so that they were getting success in releasing new products in the market. So that is how there was a very fast growth in the IoT devices in the market, but still we can see that the growth is very significant in the upcoming years, but the percentage is slightly declining. Even after that, so from 2022 onwards, like there is a forecast that still there is a good growth of the IoT based devices, IoT enabled devices, but there could be almost at the constant rate, we can expect that there is a growth of the IoT enabled device. So, but in terms of the devices that is being connected to the IoT into the, I mean, the devices that are being connected to the internet. So you can see in terms of billions. So there are about 29.7 billions of devices that are going to be connected by 2027. So that like those devices, like you can access the data of those end devices from anywhere you want. So that is the trend in the market, and also you can see which particular connectivity type is having the fast growth rate. So you can just check like the low power wide area network. So these categories are having like the 38% of growth rate, whereas the cellular and 5G IoT based devices, they have a growth rate of 200%. Like that, they are very growing at a very faster rate, you can say. And so the wired IoT devices, there are wired IoT devices as well. Like you can see, the growth rate is relatively smaller, like relatively slower. Whereas nowadays you can see again, there could be reason that why the wired IoT device could be gaining momentum at this during this period. So what is the difference that we can notice when it comes to the wireless and wired devices? That is in terms of the reliability. So to have the reliability, to have a reliable system, so always we go for the wired system. So if you don't want to lose connectivity, or if you don't want to lose the data, any part of the data, then this wired IoT is the essential part. Or will prefer IoT, the wired IoT in place of the wireless IoT devices. So this is all about the market forecast about the IoT devices. Yeah, please next slide. Yeah. So now coming to the use case studies. So as I mentioned, like first we'll be starting with the industrial IoT. So how the industrial like what are the drivers for the industrial IoT in the manufacturing sector? So why there is a why the IoT is being preferred in the industrial domain or industrial IoT domain? So you might have heard about Industry 4.0. So there is a revolution in the industry where these manufacturing sectors or the manufacturers are they are planning to adopt the manufacturing like whatever the manufacturing segment manufacturing ad, which is completely made to be a smart one. So it is known to be a smart factory. So their factory in the manufacturing sector. So basically they want to convert their factory to a smart factory. So that is leading to, I mean, there should be some motivation or there should be some drivers why they want to move from the conventional factory to the smart factory system, or why they want to adopt this industrial IoT in their factory environment or the manufacturing environment ecosystem, we can say. So coming to the different drivers, one thing is they can see the lot of reduction in the cost, since they can have the optimized asset and the inventory management. So what is this inventory management or the asset management? So see, in the manufacturing ad or in the factory environment, so mostly they face issue with the inventory management problem. So inventory management, like where that particular item is being placed, where it can be found, again where it has to be kept back. So all these are the tedious job process in the industrial environment. So if you can make use of the IoT environment for inventory management purpose or the asset management purpose, then a lot of man hours can be saved there. So if operator knows where exactly that particular item has been placed or where exactly that item has to be replaced, then it is easy for the operator to, I mean, lot of time can be saved, and also there could be some sort of automation involved where they can make up the automation system and they can directly borrow those items or directly place those items wherever it has to be. So that inventory management is one of the that is the challenging issue. Still the most of the industrialists are facing, and of course depending on the, again, the smart, like establishing a smart factory or the smart ecosystem for industrial environment, it takes time. If they are, if they are new to the ecosystem, then it will be easy for them to establish the smart environment or the smart factory. But if they are already existing in the market, if the ecosystem is already existing, if they are already in the market, then it might be, there might be quite challenges involved in establishing the smart ecosystem. So, but because of these inventory management as well as the reduced, of course, apart from the inventory management, because of uh, the machine predictions and like we'll be discussing about some of the use cases where the condition monitoring will be done, and also the health of the machine can be monitored on regular basis. If you can monitor the health of the machine on regular basis, so, and if the operator gets to know that when exactly it needs service, when exactly that a particular machine requires service, then you can actually save the downtime of the machine. You can get rid of the downtime of the machine. That is very important. See, now, like, there could be a very good revenue from the particular the manufacturer, but if in case if his machine requires service often, like, I mean, repeatedly they are seeking for the service, and if he is unable to resolve it in a short period of time, then there could be a huge revenue loss for the manufacturer, because he has invested on the machines, he has invested on the manpower, he has, like, nowadays the manpower is one of the costly investment in every sector you take. So like, in there will be, like, initial investment required in the manufacturing sector, and if the machines are having a significant downtime, then it will be a huge revenue loss. So, but using the IoT ecosystem, if you can monitor the devices on real-time basis, and if you can actually, if you can make use of some intelligent models to predict when exactly it requires service. If you know the pattern of the machine, and if there is a deviation in the pattern of machine, fluid in the machine has to be replaced. So all those minute parameters can be monitored, and it can be considered for replacing as and when required. So with that, lot of, like, in terms of inventory management, in terms of the monitoring the health of the machine, in terms of the downtime reduction, IoT uh, environment in a manufacturing sector. So shorter time to market. What is this term shorter time to market? If you have heard about this time to market is very important parameter with regard to the IoT devices. What does this actually deals with, shorter time to market? See, there is always competition between the different vendors in the market, and, like, how fast, because if you take the mobile phone, it is also basically one form of the IoT device, you can say, you can still, your mobile phone is categorized as one of the embedded devices, okay, and you can say it is a kind of the device where it falls under the IoT enabled devices, you can say. So there are a lot of vendors for selling the mobile phones, but who is successful in the market? Who is successful in the market? Yes, so there the time to market is very important criteria in deciding the of course the features that will be decided. Along with the features, though they have the similar features, how fast they are releasing that particular product in the market, how fast that particular product is being released into the market. Nowadays, if you see, there are a lot of appliances, home appliances that are being released into the market. Like if you see Alexa, Siri, there are the voice assistant devices from the Wipro. There are voice assistant devices from the Amazon. So different vendors will be producing similar products, but with slightly modified features. But how fast they are releasing that product in the market, that will also decide how much revenue they can earn or how much revenue they can they can generate. So, and in the mobile industry, you can see there are constant effort going on to update the devices. Constant effort is going on to update the devices, and if they are lagging in this particular parameter, time to market parameter, it is very difficult for them to survive. So we might have seen the case of Nokia mobiles, like Nokia mobile phones, how like once they were the big player in the market and how they got vanished. Maybe the reason might be slightly different, but how they got vanished from market. So, but if you compare with the other vendors or other players, how they are able to survive in the market, and like the time to market is one of the very important criteria for the manufacturing perspective. So there was an example where the Harley Davidson, the bike company, they leveraged IoT to reconfigure its York manufacturing facility, and they managed to reduce the downtime it takes to produce a motorbike from 21 days to 6 hours. That is the real example where by deploying the IoT ecosystem in their the manufacturing ad, you can just check with the timing, like from 21 days to 6 hours they were able to reduce the time to market. So that is very significant in the market. So if they are able to achieve that by deploying a IoT based system, why can't the other vendors, like if they don't follow, then they will be out of the market. That is what happening in the current scenario. Yeah, and of course the customization, and there is a mass customization involved, and also in case of tracking the inventory and other processes. So like there is also need for improved safety in case of the manufacturing industry, so that to address the potential problems in the hazardous environment, that will also seek for the IoT solutions, you can see. So like safety is one of the I mean very essential component, or it is like we cannot compromise the safety of the operators or the safety of the personnel that are involved in the manufacturing sector. So like how we can make use of the IoT based solution to deal with these safety challenges. So that is also a point to be discussed. Yeah. So like we'll take some of the use case examples I have included. Like we'll be having the industrial IoT impact for the different verticals. So visibility into the shop floor and the field operations. Again, if you take the different dimension, like visibility into the manufacturing supply chain, visibility into the remote and outsource operations. So how we are making use of the IoT based, like, are basically you can say the industrial IoT in uh, different dimensions or different verticals, you can say, in the industrial environment. So we'll be seeing some of the use cases here. Please go on to the next slide. Yeah. So according to the McKinsey research, by 2025, the manufacturing related operations, like there will be lot of improvements in the manufacturing related operations driven by the IoT systems, and it is predicted that so the worth could be more than $470 billion per year after 2025 in case of the IoT based, like the deployment of IoT in the manufacturing operations. And the for manufacturing related operations, so it mainly the IoT application mainly deals with the monitoring of parameters, optimizing the equipment performance, the production quality control, and also the human to machine interactions. And also in the manufacturing related operations, will also be dealing with some of the real time equipment utilization matrix, again where we'll be discussing in the condition monitoring of the machines. So like which all parameters, which all matrix needs to be monitored. Yeah, it doesn't work or? Is it working? Just check. Yeah. Long press out. Right? Yeah. So monitoring the equipment utilization, like different parameters will be monitored here. Yeah, I'll just like previous slide it deals basically with this monitoring the equipment utilization, where we have this the different parameters and the different IoT solutions are provided from the distributed computing system, then the SCADA, supervisory control and the data acquisition system, then the sensor modules, depending on the domain of application and depending on the particular case. So these IoT solutions will be provided, and from this the data will be sent to the cloud, and in the cloud we have like we can seek for different analytics there, so we can visualize the data as the I mean as per the requirement. The data can be visualized or the data can be analyzed there, so we can use some of the intelligent models for data analytics in like once the data is being fed into the cloud. So there, so some of the key performance indicator will be monitored. So like total equipment efficiency performance, or the overall equipment the efficiency of the equipment will be monitored, and like how it can be adjusted. So all those the key parameters of the machines will be monitored once they are being once the data is being acquired into the cloud. So if you can monitor the overall equipment efficiency and the overall the total equipment efficiency performance, then you can see how that particular machine is being how that particular machine is performing, or uh, like like if there is any deficiency in the machine, then the overall performance of the machine will be degraded. So those minor things can be visualized and they can be monitored, and it is up to the shop floor manager or the operator or like worker who is involved, and who can access the data and he can visualize as and required. So here, like if there is any I mean if the user is found that if there is any deviation in the normal performance, he can easily he will get the alert saying that there is a like there is a degradation of performance, and he can take the action accordingly. So this is one case where the monitoring the equipment utilization is being carried out, because the purpose of this is, again, if you can constantly monitor the equipment utilization, you can reduce the downtime, or you can exactly get to know when you can when that particular machine needs the service. Yeah, and the one thing is product quality monitoring. With regard to the product quality monitoring, like you can see, there are two ways to inspect this the product quality control. So one thing is by inspecting the work in progress as it moves through the production cycle, like how much work is being progressed. So that is one way of monitoring the product quality control. And there are other, like by using this work in progress approach, we might miss on some of the minor defects or some of the minor misalignment or minor accuracies will be missed by this particular approach, work in progress approach, to monitor the product quality control. So we'll go for the by monitoring the condition and calibration of the machine on which the product is being manufactured. So we'll go for condition and the calibration of the machine. By that means we can actually have the control of the yeah. So in case of the based on the condition monitoring, we'll be monitoring the different parameters for a particular machine. Say if your if your approach is only on work in progress, you can miss some of the minor parameters, or there could be some minor inaccuracies involved. So we'll go with the exact parameters where you'll see the calibration and the condition of the machine in terms of its speed, vibration, the environmental condition, the temperature, humidity, all these things are monitored. And if there are, if these parameters are in the normal threshold, so then I mean it is fine with the user. And if there is any deviation from the normal threshold, alert will be sent to the user saying that this particular there is a deviation, there is like strong vibration in the machine, or saying that there is a fluid that is going to be please consider replacing the fluid. So fluid is going to be empty in within short span of time. Some kind of alert will be given to the operator saying that there is going to be a deviation in the short span of time. So before that fluid gets over, or before you can before that the machine goes to the fault condition, so the alert will be sent to the user. So that is where you'll have the condition monitoring, and by monitoring that particular condition, so user or the operator can be given the alert, so that in the right time the machine can be serviced. Yeah. So along with the ambient parameters and the machine health parameters, the calibration of the machine is also being monitored. And if there is any deviation, if there are any deviation, then the deviation is being identified. Or if there is any the deviation from the normal threshold, that those will be identified, and that will be the alerts will be recommended to the operator or the user. So previous slide, please. Yeah. So coming to the safety part, so we have this operator safety. Like there are industrial applications where you could see safety is one of the important criteria. So if you take, there are hazardous environment where, like if you take the mining industry, there are like the operator where they have to go with the hazardous, they have to face the hazardous environment. So like a user can or the user can be it could be accompanied with the smart helmets, which is embedded with the RFID tag. And so using that, using those kind of, and using the different sensor modules, so the heart rate, then the temperature and other response of the personnel can be monitored on the real time basis. And also along with that, we we can also capture the location of the personnel. And so immediately if there is any deviation in the behavior of the person, or these vital parameters, if there is any deviation in the vital parameter of the personnel, so it can be reported to the cloud. And then uh, also since we are dealing with some of the vital parameters, we'll also have the ambient like weather conditions and the environmental parameters, and so that the analysis can be done. And if there is any, like again, there is always, you have the provision to use the intelligent models. So in case of the IoT based system, once you have the data, once you have the historical database, you have the provision to use the analytics to see if there is any unusual behavior, or if there is any deviation, or if some alert has to be sent to the concern, so that there is some attention required. So if there is detection, like by means of intelligent models, if there is any unusual behavior detected in the personnel, so it can be reported to the manager or the concern, so that the attention can be seen. So this is one of the safety application. And yeah, also we'll be discussing about some of the industrial asset tracking system, where, as I mentioned about the asset management part or the inventory management part, where you can see that there is a storage ad and there is a construction site over here. So like if you want to the track the asset, like where exactly that particular item is being, or where that particular asset is being located, and like instead of like randomly searching that or using the man hours for that particular task. So how if you can place a RFID reader at the exit and the entry point of the storage yard on the construction site. So there will be a RFID reader here at the exit point of the storage ad, and each of the asset will be involved with a RFID tag. So as that particular asset moves out of the storage ad, or once it moves out of the storage ad, so that will be scanned by the RFID reader, and the details of that particular asset will be recorded and it will be saved in the database and sent to the, like in the cloud database, that particular data can be saved. So that the like for a particular asset, the data could be the physical parameters, the cost of the particular asset, or the serial number involved, or the model, or the area where it needs to be used. So all those details can be saved when it moves out of the storage yard. So then you can see the different steps involved here, like leaves the storage yard, then the scan is being done, then the data, once as soon as it leaves the storage yard, then the data is being stored in the database. At the fourth step, we can say, once it enters into the construction site, yeah, then after it leaves the construction site, again at the exit gate there will be one more RFID scanner, which can say that that particular the asset that has been utilized and it has been sent out of the construction site. So then again same thing, once it is out of the construction site, that the record of that particular asset is being recorded and stored in the database. And this is how, like, there is asset tracking and management system that can be deployed in the industrial environment again, and the lot of man hours can be saved by using this particular mechanism. Of course, there would be initial environment required, and it depends on the task. So, like for which particular use case and for what kind of nature you are deploying that IoT based system. So, if the task is iterative in nature, if it is repetitive in nature, this could be a best fit for that. This kind of solution could be a best fit for that kind of the management system, asset tracking management system. Yeah. So similarly, we have the predictive maintenance condition monitoring, where we have the real-time data, like could be different parameters associated with the machines, like temperature, pressure, vibration, frequency, and all those parameters will be captured in real-time basis. And then along with that, we have the metadata of the machine, like from the manufacturer's case, like we might have the data related to that particular machine, and the also the previous the usage data, and the data from the ERP maintenance system. So all those data can be utilized, and we can perform the data analytics for there. And so of course there are like lot of machine learning models available now, so which can predict us, or which can tell us that like that particular machine is like whether it is in the good condition or whether it is in the faulty condition. So there are very simple use cases involved in the in the predictive monitoring, in the predictive condition monitoring, where actually if you just check with your table fan, and if you insert some faults, or if you make it noisy kind of environment there, and you can acquire some of the data there, and you can acquire data with the normal working condition of the table fan, and you can acquire the data with the noisy working condition of the table fan. Later on, if you apply the machine learning model, and it can classify that like what is the regular pattern and what is the noisy pattern. So similarly with the machines, the different parameters will be captured. Again, it depends on the different that machines being involved. So different parameters can be captured, and it can be the machine learning models can be used, and you can detect the potential threats involved or the actual condition of the machine, and the alert can be sent to the maintenance the specialist, and also the shop floor workers will have the access to the cloud data that is being received on the real-time database. Yeah, please. Yeah. Coming to the benefits of the industrial IoT in manufacturing, see, like as we have seen there at the initial slide, like why there is a like what are the drivers that are driving for the industry IoT in the manufacturing sector. So now coming to the benefits, like there are a lot of benefits with regard to the product quality and the defect tracking, real-time supply chain management. So of course we have the asset tracking and management system, then the improved contract negotiation through the supplier performance data. So since we have the like IoT enabled systems, so we can say that we can actually prove that how our particular machines are performing, or if you can have that data, and like we can negotiate with the clients and say that this is how our devices are performing, and that all the business level contacts can be established by means of the IoT based systems. So faster and cheaper product prototyping. Obviously, we have seen some of the examples where the like the manufacturing ad like in the for the bike manufacturing ad, where it reduced the manpower from 21 hours or time to market from 21 days to 6 hours. So that is how we can go for the faster prototyping, output and the demand forecasting. So like how much like demand forecasting, how much actually required, that also we can predict by means of the industrial IoT, by means of providing the IoT solutions. So yeah, yeah, a lot of things we discussed about the industrial IoT. That was one of the use case involved here. Intentionally, I dedicated more number of slides for the industrial IoT because that is one of the domain where the lot of IoT, there are a lot of challenges involved, and there is a need for the IoT solutions. So recently I've been to the HL Academy in Bangalore. So there, like aerospace related, I mean they have their own I mean the factories related to the aerospace, where they are facing a lot of issues with the inventory management part. So inventory management is one of the tedious process in the HL the industrial environment. So they were seeking for a solution for that exactly. So even the HL people also, they are seeking for a solutions, but these solutions are mostly incorporated where like where actually who have the very good revenue generation in the market, or like I mean very big players you can say. But like most of the industrialists, like the industrial environment, yet to adopt this the environment IoT based solutions, yet to be adopted in the most of the industrial ecosystems present in the I mean that too in particular to the Indian scenario if you consider. So still there is a lot of scope in case of the industrial environment case, because that is one of the sector where very high revenue will be generated, and if high revenue is being generated, of course you can I mean with the minimum initial investment, so these smart solutions can be provided, and they can they can get the benefit of the industrial IoT ecosystem. Yeah, coming to the IoT in agriculture, transforming the future of farming. So yeah, so there is something called precision farming. Have you heard about this term precision farming? So what is, like there could be smart farming as well as the precision farming. So smart farming you might have heard, like where we'll have the smart irrigation system or the smart recommendation system where like if a particular crop is affected by so and so disease, so it can be detected automatically and you can recommend some of the solutions for that. So, but when it comes to the precision farming will exactly speak about in that particular region. If you take if there are some commercial crops involved, so with regard to that particular crop, what is the temperature involved, what is the quality of the soil involved, like what is the fertility of the soil there, what is the pH content of the soil, and that what is the water uh, withholding capacity of that particular soil. And for that particular region, for very local region, you can say, to be very specific, for that particular region, like what is the intensity of sunlight, what is the ambient temperature, or what is the wind speed in that particular location. So it is with regard to that specific location, and not in general speaking about for that particular farm I have incorporated the IoT based system and that becomes a smart farm. So because if you like, I mean in general, if you take acres of land, so for 1 acre, I mean for 10 acres, if you incorporate one smart IoT based system, can it handle or can it give a precision result? Can it give a accurate result? So there is something called precision farming where actually it takes care of the parameters, like different parameters, like all the minor considerations will be taken care, and accordingly if you can give recommendation to the farmers. So of course in turn the precision farming will in turn it will give uh, the the good crop yield. I mean there will be significant improvement in the crop yield along with the sustainable agriculture practice. So sustainable agriculture practice, how do you justify that you can have the sustainable agriculture practice by deploying, by incorporating the smart farming or the precision farming? So of course you can save a lot of water. How you can save a lot of water? If you incorporate the precision farming. So precision farming is to such an extent that for a particular crop, of course there will be a periodic routines where a particular crop needs to be irrigated. But what if there is a forecast saying that there is a likely to rain for tomorrow and the schedule is also for tomorrow. The irrigation schedule is also scheduled for tomorrow and there is likely to rain for tomorrow. And once it rains and thereafter if your automated system is irrigating the land, then lot of resources going waste there. So how we can coordinate with the forecast system and then we can, if we can irrigate the field accordingly. So that is one thing where all those minor cases will be considered, and also if you can actually check the condition of the soil, how much moisture content is present in the soil, based on the moisture content of the soil, if you can plan for the irrigation schedule. Okay, and what is the nutrient present in the soil, and based on the nutrient quality of the soil, if you can like now the farmers, like mostly in the conventional method, if you say, so like they'll be applying a lot of fertilizers to the crops. So if they exactly know like what is the amount of fertilizers required for the crop based on the measurement of the pH quality of the soil and based on the measurement of the, like based on like inspecting the fertility of the soil, accordingly they can supply the fertilizers to the crop. And also for a 10 acres of land, so the fertility of the soil may not be consistent. So how all those the minor cases can be considered and you can go for the precision farming. That is what the point of interest in case of the precision farming based solutions. So nowadays the precision farming is like, I mean there are already solutions available in the market. Please go to the next slide. Yeah, so you can, it's working now. Yeah, so lot of data driven smart farming. So we have a device from the fussel.co. Please move on to the next slide. Yeah, yeah, no, next slide. Yes, next. Yeah, so uh, this is the one like device that I've come across where like this particular like system, uh, like a lot of sensors are embedded here where they have incorporated the winds, the sensors for measuring the wind speed. Then it is also equipped with the solar panel. Then they have some sensors for measuring the moisture content. Then some of the sensors for measuring the pH quality of the soil. So and like the two some like uh, uh, industrial quality or industry standard sensors they have been these systems are equipped with, where actually they can detect the precisely they can detect the fertility of the soil. And also this system, the data can be gathered in a gateway from, there are different uh, different kind of like you can see here there is a the gateway involved here. So from this gateway data can be accessed, like the different sensors involved here will send the data, or by means of wired communication itself the data can be gathered into this gateway. So if you are using a wired communication, that is more reliable, so data cannot be lost, or again there could be cost factor involved here. So using wireless and wire, like again depending on the domain of application you can decide it. So for a particular application, if cost factor is one of the crucial thing involved, then if you can solve the problem by means of wired communication, and if it is working out for you, like if it is giving a providing a reliable solution, then definitely you can go with it. So once the data is being collected to the gateway, from the gateway you need to transfer the data to the cloud. That is the next level. So but getting the data at the gateway, and again there could be different such kind of systems deployed in the farm. So this is one system where you have the different, where it can actually the acquire the data by means of different sensors. So similar like similar kind of setup can be installed at the different places of a farm, and the actual parameters related to uh, the the soil, the moisture content, and then the related to the wind speed, related to the intensity of sunlight. So all those parameters can be captured, and the decision can be taken accordingly. So since it is a data driven smart farming, so the irrigation alert, as I mentioned, like how irrigation alert can be provided. Then the weather forecast, it also deals with the weather forecast, saying that there is, today it is going to be cloudy day, today it is going to be a sunny day, or today it is going to be a rainy day. So that way that kind of forecast can be provided, and accordingly not only the farmer will take the decision, so your the automated machine itself can take the decision, because it involves the intelligent systems, because the AI models are incorporated in this, where it can make the intelligent decisions, and that recommendation can be provided to the farmers instead of farmer deciding that whether to irrigate the land or not. So the machine will decide whether it is the best time to irrigate the farm or not. Similarly, if there are like disease and pest alerts also be given based on the weather condition. So again, if you want to actually detect the whether a particular crop is affected by disease, again the image processing related work will come into picture, but that is not incorporated in that kind of system. But of course, that is the scope where we can also incorporate such kind of systems, and the on interval basis pictures can be captured and it can be managed. But based on the weather condition, the alerts can be given, so that some of the pesticides can be sprayed, or by means of the fertigation mechanism it can be supplied to the crop. So all these all these activities can be kept on the record, like it can be saved, and it can be so mostly for the commercial crops that are involved. What happens is, like, it is very hard to get the previous history. So if you have the past history of the crop, like for that, like before 2 years, what was the, like, how these, what is the growth rate of the crop and how the crop has come up in that particular form. If you have that history, it is very easy, or it is very useful information for the next season, so that like if you have that data, machine can make use of that data and it can provide very like good recommendation for the farmers accordingly. Yeah, please. Yeah. So of course, in the next use case, we'll be discussing about the IoT domain in the healthcare industry, where we have the lot of use case of IoT in the healthcare industry. So, like in general, if I have to discuss this, the use case of the IoT domain in healthcare industry, of course, if you can nowadays there is a term called something called uh, the Internet of Medical Things, IOMT. So that is one buzzing term. So where the if the medical devices are the, if the vital parameters, if they are being monitored by the IoT enabled devices, they are coined under IOMT, that is Internet of Medical Things. So like of course, for saving the record and fetching those record at the later stage, once it is being saved to the cloud, it becomes a easy task for the healthcare professionals to analyze such things. And also, if they have the previous history of the data, previous history of the patient, it is easy for them to analyze the data and make the prescriptions accordingly. So if by means of the AI models, the it is, if they have the different vital parameters data, and they can easily like decide like how the patient can be dealt with. So that's how we can say that usage of IoT, cloud computing and artificial intelligence is involved in case of the healthcare industry. And if you just take some of the examples where, like in the ambulance vehicle or in the emergency vehicle involved, there is a very good use case of a IoT system where a patient can be monitored. The vital parameters of the patient can be monitored on the real time basis, and alert can be sent to the medical professionals or the nearby hospital. And and if it is a very critical condition, before the patient arrives to the hospital premises, the health professionals can take decision accordingly, and they can keep, they can keep ready for whatever the requirements for the patients accordingly. So they can make the arrangements accordingly, and they can treat the patient on an immediate basis. So that is possible in case of the emergency situations or emergency conditions. So similarly, just please move on to the next slide. Yeah. So yeah, similarly we have one use case where nowadays we have the smart watches where the data is being recorded on the regular basis, and like on the real time basis, and the data is being uploaded to the cloud. And the real time, the analyzation of the data analytics can also be performed. So again, vital parameters will be chosen, like the heart rate monitoring, then the blood, the BP of the sensor. So mainly those parameters will be considered. And so if it is stored in the cloud on the real time basis, so as and when required, the analytics can be performed. and and if there is any deviation in the health of the user, so the alert can be sent to the healthcare professionals, and it can be taken accordingly. Yeah. So Coming to the use case of the smart cities, so we have like a lot of use case for the smart cities where uh, uh, like different components are involved in the smart cities where we have the in terms of the IoT like data analytics, connectivity, the smart infrastructure. So we have a lot of components where there is use of IoT in the under the smart city umbrella. So if you take an example of a use case where you might have, I mean, in the morning session there was a use case of where smart home has been discussed. So like smart city is a bigger umbrella. Again, if you take building utility case or building energy management case, or if you can take the waste management system, or if you can take a water management system, or if you can take a intelligent transportation system. So all these different use cases falls under the smart city umbrella. So and also the smart administrative system nowadays. So that is also part of the smart city initiative. So there are a lot of use cases, and if you see, there are some of the successful smart cities, like for example if you take the Singapore, then the Barcelona, or these are like Barcelona, Spain. So these are some of the cities where they are they are earning, I mean, they have turned their economic status by means of deploying by having this the smart city strategy. So by having the smart city strategy in their economic, they have revived their economic condition itself. So I mean, like you just move on to the next slide, please. Yeah. So these are the some of the successful countries, like where the Barcelona in Spain, you can see that they have implemented the sensors for the waste management, like smart waste management purpose. Then smart lighting systems are being deployed for the energy efficiency, and uh, so positive impact on the cleanliness, like reduce energy consumption and the overall citizen satisfaction, they are able to get by use of the IoT based solutions. And as I mentioned, so IoT based solutions mainly, if you are listing it under the smart city, so like smart city is a bigger umbrella where you have the building management system. So in the building management system, if you just consider the use case of energy management, so there is a lot of scope for negotiating the energy itself. So how it can be, how that can be achieved, and of course when it comes to the city, so there are the smart lighting, how we can minimize the energy consumption of the street lights. That is one the use case that is I mean, that is being deployed successfully in this Barcelona city. Along with that, there are smart parking systems. So in the Barcelona city, like they have the more tourist visitors, where I mean, uh, like uh, like the parking is one of the major issue there, major concern there. So by means of having the smart parking system, so they are able to the park the vehicle in the appropriate space available. Like alert will be sent to the drivers, like there is a parking space available here in the nearby location, and accordingly the driver will be guided to that particular location where the parking space is available, and accordingly he will park his vehicle. So that way there are a lot of initiatives, of course, in the in with the waste management perspective. Now in our country also you can see there are a lot of initiatives with regard to the waste management solution, IoT solutions, where a particular bin, if that particular bin is being filled, alert will be sent to the alert will be sent to the municipality saying that that bin is being filled. Consider like consider replacing that particular bin. Or there are use cases where in Barcelona, they have the underground piping system for the waste management, even for the solid and other liquid waste management. They have the underground piping system that is again deployed by means of the IoT based solution as well. So similarly, Singapore is one of the smart city, like, and Barcelona, like if you go back 10 years back, like they were actually, their economy was a very, very bad condition before they adopted the smart city initiative. So they come up with the smart city strategy, and they were able to revive their whole economy just because of the smart city, the implementation in their city. Okay, so, and coming to the Singapore, like Singapore is also one of the top city, like, which is like one of the top smart cities you can say in the world. So where the smart transportations with the IoT enabled traffic management system. So like to avoid the congestion in the transportation, so the urban mobility is being introduced, or where they will reward, or the bike sharing facilities being also introduced, or like slowly that is also coming up in our country. So that way they are like they are trying to create a sustainable environment. Okay, and for elderly people they have some dedicated IoT based solutions where they are trying to make some of the interactive environment for the elderly system, so that to avoid some of the health issues, so that since the elderly people are staying alone in, like that is the case with the Singapore. So they have some the interactive environment, interactive IoT environment, so where it keeps the elderly people engaged. So that is how they are treating some of the health issues of the elderly people in like in the under the smart city initiative, you can say. And of course the all of the cities involved here, like in terms of the energy management, their focus is in terms of the energy management, in terms of the waste management, in terms of the water management, in terms of the urban mobility, how they can avoid the congestion. And then again, of course, it connects with the smart parking as well. And in terms of the smart administrative system, so how the smart administration can be achieved by usage of the IoT based systems. So uh, like there are n number of use cases they are adopting in their in their country, and by having that those use cases, so like they are creating a like very good user comfort, uh, user comfort environment for the residents, as well as the visitors to their place, and that is how they are also reviving their the economy. Please move on to the next slide. Yeah, so yeah, that is how, like, the overview of the Barcelona city, like in terms of they have their own app where they can share the bikes, and so that the urban mobile, like congestion can be avoided there. Then the waste management system, then the like something related to the smart mobility, like they have an app called A Park B, where the smart parking can be deployed there, and they have some the other innovative solutions where they can build synergies between the different innovations that are required for the city. So and also like you can see that the it has gained some of the awards in like Europe Innovation Capital of 2014. So Mayor like innovations challenge in the 2014. So like Barcelona is one of the best example where this particular country, just by adopting to the smart city initiative, or like by deploying smart city initiative in its country, it is able to revive its whole of the economy. Okay. Yeah. So this is, yeah, intentionally I have included this particular slide like where we have this smart management system. So in particular to the use case of energy management, where we have this the forecasting system here, then we have the intelligent energy management system, and then the remote monitoring system. So this is one of the use case of my PhD work, where I had deployed this particular hardware setup where it has a gateway part and different the smart sockets were involved, so which can actually monitor the energy consumption of this smart socket, and by knowing the availability of the energy that is being forecasted from the generation, a generation could be different, I mean it could be a different source of generation. By knowing that generation, or like I mean the main purpose was for a solar generation, the energy generation from the solar is not consistent throughout the day, so it is uncertain or unpredictable. So knowing the generation or knowing the forecast for tomorrow, how I can schedule my appliances, that was one of the use case. Or knowing the availability of energy, how I can schedule my appliances or how I can assign the priority to the appliances. So there are some optimization algorithms being used where I can depending on the availability of energy and depending the different constraints that are involved. Again, there are a lot of constraints involved. If it is a resident consumer, if it is a domestic, like if it is a commercial consumer, if it is a industrial consumer, there are different constraints need to be considered. So for resident consumer, if you check, like user comfort is one of the main concerns. You should not disturb the user comfort of the resident consumer. So similarly for the industrial consumer and the commercial consumer, there are other concerns involved. So the time of usage. So that way, depending like considering different constraints, how best you can schedule the appliances. So that was one of the use case. Like, and nowadays there is a scope where, see, if you want to manage a particular appliance, you need a socket or you need a smart socket which can measure the energy or which can communicate, which has the communication capability. So to avoid that, nowadays there is something called non-intrusive load monitoring. So using just one energy management setup at the distribution center, you will be able to manage the consumption of the whole building. That is possible because of this the machine learning and the involvement of the deep learning. So deep learning, where you can actually capture the signature of the appliances and you can easily decide which particular appliance is that by just having the current and voltage characteristics of that appliance. Only the, again, that is also one of the data you can see. By having the voltage spikes and the current spikes of that particular, I mean voltage characteristic and the current characteristic of a particular appliance, you'll be able to decide which particular appliance is turned on or which particular appliance is turned off. That is the power, like now the integration of IoT and the AI has. So all the smart, like all the socket will go redundant, and by having only one centralized device, you'll be able to control all the appliances and you'll be able to negotiate the power of the appliances as well. Yeah, yeah. I think you must be aware about these basic things. Like I think I'm might be running out of time. I'll just slightly rush the things. So edge, fog, and cloud. So there is like you can I mean, if the device is known to be the edge device, it is placed close to the location where from where the data needs to be fetched, and the fog is again from the edge device. The data can be directly sent to the cloud, but again depends on the requirement. So if your requirement is like if you don't want to do the computation and if you want to send it to the cloud, there are of course pros and cons involved, but like edge device is the device which is placed close to the location of the appliances or from where you are to fetch the data. And if that computation has to be performed at the edge device itself, there are advantages. So you need not send the data to the cloud. By doing so, lot of latency can be minimized, and by processing the data at the edge, there is an advantage that the data can be sent back on the real-time basis. And if you are sending the data to the cloud, so one thing is you are not utilizing any resource at the edge where you are directly relying on the cloud, but you need to have a very good connectivity. The connectivity is the constraint that is involved if you are sending the data from edge to the cloud. Again, requirement of fog node, that depends on the how much computation you want to perform. So if that computation can be handled only at the edge level, or if it can be handled at the cloud level, you did not include the fog nodes. So that is how, depending on the domain of application, depending on the particular use case, you can consider placing the different layers. So whether you need to include the edge layer or fog node or the cloud, it depends on the particular use cases. Yeah. Now we have, there is something called augmented reality and the virtual reality. So you must be aware that, so this augmented reality and virtual reality, these are the technologies in the current days where it can either enhance the real life environment with the simulated ones, or it can replace the whole real life environment with the simulated ones. So now, like you might have seen while ordering the Flipkart, while ordering the items in the Flipkart, they have implemented this the augmented reality. So if you are ordering any item, or like if you are ordering any chair or any cupboards, you can actually see how that particular the item fits in your room. So that is how they are using their augmented reality. That is and now like there are very good use cases of virtual reality in the industrial environment as well as in the healthcare applications. That is the next generation use case, you can say. So I have some videos, like if you can just maybe you can play that. That will be more like trends. I'll be taking very short time. Yeah, just you can go to that file. First one, no, just yeah, go to that. Yeah, 1 2 3, what is one? Yeah, that video is, audio is available. Folder you can open and you can just, yeah, there, first video you can play it. Is it working? Check in the video down. Media player. No, no, first one. Open. Yeah, Windows. Close. First one. Working. It's okay. Leave it. Movies and. You just check that if that link works fine. It's okay. Okay. Yeah. Yeah. You just. Yeah. We'll go ahead with the next slides, please. Like trends. Yeah. Trends in IoT. You can just. Trends. No, no. Just go from here. Yeah. So I'll just share those video links with you. Maybe I think you can just go through. Yeah. So coming to the trends of IoT, like we can see again, yeah, as there is like the integration of AI, that is AI, artificial intelligence technology with IoT, and like a lot of things can be like as you see that analytics can be done, and a lot of insights can be derived. So there are now at early days you had the constraints of the computational power. So now there is availability of the computational power, and so nowadays it is possible. So you have the good connectivity and good computational power and integration of AI and IoT. You can do like I mean you can derive. You can go for a lot of analytics. You can go for a lot of the insights can be derived for a particular use case, and that is possible with most of the use cases that we have discussed, and like that is the trend where we are moving forward. So earlier it was not possible because there were concerns with the computational devices availability. So coming to the edge computing, again as I mentioned, if you differentiate the edge computing with the cloud computing, so cloud computing, it has its own advantage where you can actually minimize the latency. So for any applications, so I choose one of the applications where the ambulance device, if it can, if the ambulance vehicle, if it can coordinate with the smart traffic lighting and on real time basis, so there should be a provision where as soon as the ambulance vehicle comes, there should be a green signal for the green signal from the traffic light management system. So that can be made possible by means of this edge computing. So the data has to be processed on the real time basis, and it has to be sent back without any latency. So that is the direction. Of course, along with I mean, there are a lot of sensors used now. There is the domain where a lot of video analytics is carried out, and I mean, as I mentioned, the traffic congestion system related to the emergency vehicle. So that is handled by the video analytics as well. So there, the low latency is one of the requirement over there. Of course, along with the low latency, the security is also matter of concern. And now, because of the 5G connectivity, you are able to, like achieve, you are able to transfer the data at the faster rate. So that is what required in case of the IoT enabled devices. So if you can transfer the data at the faster rate, lot of things, lot of use cases can be deployed by having the a good connection. So as we discuss the predictive maintenance or the whatever the smart factory related use cases, all those needs a reliable communication. So real time communication along with the reliable communication. If communication can be achieved with a, I mean, if the data can be transferred at a very faster rate, so now like there is something called like whatever, like the virtual reality, where the the remote surgery can be performed by the healthcare professionals if you have the very good internet connections, and that is one of the futuristic plan with some of the companies are coming up, where the health professional or doctor is at one location and patient is at the other location. They are able to perform the surgery remotely. Of course, there is a role of doctor, but they are at the different places. The robots are involved, which can mimic the hands of the doctor, and it can perform the surgery. So, and already it is being tested. But for that, you need to have a very faster the internet connections. So there are a lot of use cases in the healthcare still. Of course, now we are able to monitor most of the parameters, but when it comes to the healthcare, the how we can diagnose the health of the parameters. So again, now we are able to acquire the data since there is the integration of the AI domain. So we have a lot of other scopes involved in the healthcare domain. So if you have the data and if you have the computational devices, like how the analytics can be performed and the insights can be provided to the healthcare professionals. So smart cities, of course, there is a lot of scope with regard to the smart cities. Again, the smart cities, if you take, again, it could be related to the energy management thing, or any other the initiatives related to the smart city umbrella. So because like there are lot of scope where a lot of challenges are still present in the smart city, where you can make use of the IoT and like provide the relevant solutions. So blockchain is one of the domain where like in the finance related to have a secure transactions, like the blockchain domain is being utilized. So that is one trend, and again like that is also one of the the trending area with led to the block associated with the blockchain in case of the IoT domain. So these are the different trends associated with the IoT domain, and mostly because since you have the computational capability of the device, along with the computational capability of the device, you are able to integrate the AI models. So because of that, you are still able to see there is a lot of scope involved with the IoT domain area. Yeah. So yeah, I think with this I'll end my session. Yeah. So if you have any queries, yeah, please let me know. I think we'll be able to interact. Yeah. If there are no queries, yeah, I think we'll end the session here. Thank you.
Thank you, sir, for sharing your knowledge. We appreciate all the valuable insight you have provided. Now, I would like to request Professor Sunil Hebale, sir, to present the memento to our today's resource person, Dr. Prakash Pawar. Thank you, sir. Sir, there is an announcement. Today we are planning to visit Kedrapur Kopeshwar temple after the hands-on session, that is at 4 p.m. and will be back by 7 p.m. Interested participants can join for the same. College bus facilities will be arranged. Only for faculty participants. I request everyone to follow for lunch break.